Assalamualaikum, my name is AINURYUSRA binti Muhammad ZAWAWI. So today I will explain about our project, which is Atomizer parameter. Okay, but first let me explain about what is Atomizer. So basically, atomization can be performed by different types of atomizers, which are pneumatic atomizer, pressure nozzle, spinning disc, fluid nozzle, and one more, sonic nozzle. So basically, this project is using a straw as the tube to design mini atomizer prototype. Okay, regarding this project, it will use Bernoulli principle because it will describe in which fluid behave. Basically, in all this, an approximation relation between pressure, velocity, and elevation can be determined. By doing this project, we will apply the knowledge, basic features, and configuration of engineering technology. Yep. Besides that, we will also be able to learn and explain effectively regarding Bernoulli's principle. Okay, so basically the objective of this project is to apply the Bernoulli's principle of the spray that we use daily, and also to solve the Bernoulli equation. Lastly, the objective of this project is to explain the fluid condition such as fluid pressure, velocity, density, and also the height at one point of along the flow streamline.
Literature review. Bernoulli's principle. Bernoulli's principle is a relation among the pressure, velocity, and elevation in a moving fluid, whether it is liquid or gas. The compressibility and viscosity of which are negligible, and flow of which is steady or laminar. Bernoulli equation. The Bernoulli's equation, usually written as flow work plus kinetic energy plus potential energy equal to constant. Derivation of Bernoulli equation. Derivation of Bernoulli equation has three statements, which is static pressure, dynamic pressure, and hydrostatic pressure. The relationship between Bernoulli's principle and Bernoulli's equation. Bernoulli's principle contained within Bernoulli's equation, and assume that there is no change in the height of the fluid. The term is cancelled if subtracted from both sides. For example, flow work plus kinetic energy equal to flow work plus kinetic energy. An increase in speed must be accompanied by a simultaneous reduction in pressure, so that the sum always adds up to the same number of constants.
In fluid dynamics, Bernoulli principle states that an increase in the speed of fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid potential energy. We want to prove that Bernoulli principle can be used in daily life. We have made some research to find out what kind of project that we can make by using Bernoulli principle. And we find out there is a Swiss physicist, Daniel Bernoulli, formulated that the Bernoulli's principle. It describes the way in which fluid behave. According to it, pressure decreases as the speed of flow increases within a stream of fluid. Similarly, pressure increases as the speed of flow decreases. The action of our atomizer is based on Bernoulli principle. According to it, pressure decreases as the speed of flow increases within a stream of fluid. Similarly, pressure increases as the speed of flow decreases. In our project, the air flow with high velocity through the tube when air pump is turned on. A region of low pressure is created just above the tube due to the flow of air at high speed. Due to this, the water leaves the tip of the tube. We are decided to make a mini atomizer by using the recycled product such as plastic bottle and aquarium tube. For project costing, we are discussing it almost 6 days. It is because there are some problems that we face during the project construction. At first, we want to use new item, but we lack of budget. Other than that, the product that we want to buy at the hardware shop is out of stock. Then, we design our product too complex and it need huge budget. At the end, we only use the recycled product to build up our project.
Assalamualaikum. My name is Muhammad AISAMUDDIN SYAHMI bin ZUSDI. Today, I would like to show you the parts and the materials that we are using to make our own prototype. Without you realizing it, this prototype is based on our daily life usage, which is the spray. Okay, the first materials that we use are plastic bottles. The second one is an aquarium bubble hose. And the third one is the T connector. Okay, the parts where we use to produce the flow of air around this hose. And now, I would like to show you the calculations of our project, which is to find the minimum velocity of the pump. As you can see here, we have stated all the data that we have in order to find the minimum pump velocity. They are constant, the diameter of the pump, the diameter of the bubble hose, the height of bubble hose, the density of water, the bicycle pump pressure, and the temperature. First, by using the Bernoulli's equation, we will cut all the equations that we consider doesn't exist in our project. We will find the main equations in our project. And for the water, we can conclude that the pressure 1 minus atmospheric pressure is equal to negative rho of water times gravity times height. Then next, we will find the density of air by using the formula rho A equals to pressure of bicycle pump over the R constant times temperature. And we will get the answer that the density of air is 4.837 kg per meter cube. Next, we will find the velocity of the bubble hose by using the Bernoulli's equation, and we will get the answer is 22.06 meter per second. Then lastly, we will find the velocity of the bicycle pump, and by inserting all the data that we have found from our previous calculation, we will get the answer of the velocity of the bicycle pump is 3.53 meter per second. That's all from me. Thank you.